What's up, guys? It's a great day at FlexArm. My name is Tyler, and what I got for you today, a potential client sent in some material for us to tap. It is about 2-inch thick stainless steel. Here's the kicker though. We're gonna be running that with an 1.5 inch NPT tap. So the prospect was currently tapping in the radial drills, snapping taps off like crazy, and he's like, Tyler, I need a solution. You know, I can't be snapping taps and scrapping parts. I said, hey, go ahead and why don't you send me some parts and material. I'll go ahead and run a tap test for you to prove out our solution, to give you the warms and fuzzies before making a decision on the FlexArm. So the way the tap test went, we started out about 50 RPM with our GH60 tapping arm. That's 2-inch capacity, rated for mild steel. So this tap test definitely challenged the arm's limits, but as you'll see here, we went ahead and started running the tap in to the material, and it started clutching out prematurely. So what that tells us is that A, the tap's getting dull, or B, we gotta tighten the torque settings there in the tap holder. So we made the proper adjustments, slowed down the RPM to generate a little bit more torque, and then we went with a step or a peck tapping method. And what that's going to do, especially tapping into stainless steel, is that it's going to break that chip off a little bit easier so that the tap can easily pass through the stainless steel material here. So I got a challenge for you. You got some exotic materials, some hardened materials that you guys are tapping by hand or breaking into CNC. I challenge you to send my team some of your tools and parts so we can prove out to you how much value the FlexArm can truly bring to your business. And if you don't believe us, send us parts in, we'll prove it out. We'll even send you a 30-day free trial to make sure that your operators and your guys running the machines are comfortable with everything that you're gonna get, along with the customer support to back it up.
Hey, it's Eddie here with FlexArm. We just had an end user reach out to us looking for a better tapping solution to help reduce production time without sacrificing quality. Now, they manufacture custom aluminum extrusions of all shapes and sizes and currently tap these parts in the CNC. Now, before they invest in our solution, they wanted to see if the FlexArm could truly help speed up their operations. So to demonstrate the capability, we tapped their part using an 832 tap and paired it with our A32 pneumatic tapping arm. The FlexArm was able to quickly and easily tap all the holes in the extrusion in much less time than it would have taken in their expensive CNC. Their current tapping process takes minutes to complete, and with some parts having up to 18 holes, the extra time is absolutely killing their productivity. However, the FlexArm decreased downtime significantly by tapping the part in just a matter of seconds. So if you're looking to free up your CNC, speed up operations, and you're ready to start flexing on your competition, give us a call at 1-800-837-2503.
All right, everybody, today we're going to go over the helicoil tapping arm. I'm going to show you guys a demonstration and a little bit about what makes this arm such a great unit. We'll start with the assembled arm here. So you'll see we have our 1500 RPM helicoil motor, our filtered lubricator with the built-in regulator. That way I can dial my PSI for my front end assembly depending on the size helicoil that I'm going to be running. So you'll see these arms are nicely equipped with a roll that we can put right on the arm, and we put the helicoils in a strip feed here so that we can do fast, easy helicoil insertion for any of your thread repair. All right, so starting with the motor, you'll see this is the helicoil motor, 1500 RPM motor that we use for driving the helicoils. Each motor comes with a small adapter, or a large adapter, or a small adapter. So these adapters are used as bridges for different sizes of front end assemblies. So in this case, for the large, or for the small adapter, we're going anywhere from, this is for the 256 to 1/4 inch front end assembly. And then this is our large adapter for 5/16 to 1/2 inch. And this adapter goes onto the motor, and this is what is used to bridge the motor and the front end assembly. Everything's left-handed thread. So we put that on, and now the motor's ready to receive a front end assembly. The other component I'll show you, it's a friction clutch. So the friction clutch is used for our small adapter for your small helicoils. So anything from 256 to 440 is what I'm going to use or recommend the friction clutch for. In the small adapter, we pull out the stock insert and we put in the friction clutch. And this is just really going to help us with those smaller holes to limit the torque and stop us from damaging our front end assembly or the threads that we're repairing. So next you'll see, this is an example of a front end assembly. This is a 3/8 16 front end assembly. This is our nozzle. This is the mandrel. Each one comes with a bag of cushions and spacers. So we use the cushion goes into the large adapter, and it helps cushion your mandrel, your driver. And then different spacers here for setting my depth. So that way, another advantage with the arm is you can set the depth. So that way I can drive the helicoil to the proper depth every single time. And I'm setting that here with these spacers, and I'm putting it on my mandrel. So I'll put one of these on here as an example. And we'd place one of our cushions inside the large adapter here. And we place the front assembly on. And again, left-handed threads, and that's about it. So now we're ready. So today, what I'll show you, I've got my arm set up here to drive quarter 20 helicoils on this strip feed, and we've got a nice aluminum piece here ready to place those. This is a blind hole. We're going to drive them to the bottom. Depth's already set. Automatically revert. So it automatically drives it to the depth and then automatically reverses. So you'll hear the motor has a hissing. That's normal. It's designed that way. First things first, I'm going to set my pressure here. So something to note is every front end assembly has a desired PSI to set your air pressure correctly for the helicoil. So in this case, it's set for 45 PSI. So I'm going to take my regulator, I'm going to adjust my pressure, set it to 45, lock it in, and now we're ready to drive the helicoil. So I have everything set up here on the strip feed knob. So I'm just going to simply line the arm up over the hole. I'm not going to fight it. I'm going to let it do the work. So we'll drive it on down. Automatically reverse. Now we have a perfectly placed helicoil. And that's all I have for today. If you need more information on our helicoil FlexArm, give us a call or shoot us an email. You can visit our website at flexmachinetools.com or 800-837-2503, and we look forward to helping you out with your next thread repair job. Thank you.
Hey guys, it's Tyler here from FlexArm. We recently had a prospect reach out to us looking for a better tapping solution. National Enclosure Company out of Michigan is a nationally ranked advanced facade contractor, and they were looking for an efficient way to tap the end of an aluminum extrusion. They're currently outsourcing these parts or tapping them in-house with a hand drill. The problem with outsourcing is that they have no control over the quality or consistency of their parts, and their volume is way too high to continue the slow process of tapping with a hand drill. I told them to send some parts in and we could run a tap test on the FlexArm. The extrusion needs 2 inches of total thread depth and needs to accept a set screw in the end, so we fixtured the part horizontally and decided to go with the GHM18 hydraulic unit. This has the multi-positional head, which will allow the operator to tap horizontally and easily reach their desired thread depth. One issue that we ran into in this tap test was chip evacuation. The end user supplied us with a straight flute pulley tap, but due to this horizontal positioning, the chips had nowhere to go. We swapped the tap with a 3-flute spiral point tap, which helped us pull the chips out of the part. The tap test was a success, and the FlexArm had no problem tapping the part to the correct depth. So if you're experiencing any similar problems or just looking for a better way to speed up your tapping process, go ahead and give us a call at 1-800-837
What's up, everybody? This is Eddie from FlexArm, and we are coming at you live from our beautiful facility here in Wapak, Ohio. And we have an amazing live stream for you today, coming at you via YouTube live stream with our good friends at OSG. So before we get started, a couple housekeeping rules. You're going to notice here on this side of the screen, we do have a comment section. Want to really highly encourage each and every one of you, if you have comments, questions, or anything along those lines, make sure to bring those in the section. We'll be pulling those up so we can answer your questions in real time. And we also have a couple of our proud partners there in the chat to be able to answer those questions as well. So you also notice on this part of your screen, make sure you give us a subscribe, hit that bell so we can keep you up to date with all the notifications, and give us what my daughters would say is a huge thumbs up. So as we get started here today, we have a very special guest that's going to help feature some of these OSG NPT taps. The tap master himself, VP of Sales of OSG, my man, Danny Nichols. Danny, how are you doing today, man?
Doing absolutely fantastic. Given the situation that we're in, I know my entire sales team is very optimistic and excited. We're reaching out to customers. We're still being able to perform a lot of our duties, and like everyone else, we're just excited about promoting and selling our product, and hopefully we'll be able to get back out there and get to visit a lot of our key accounts again.
Amen, Danny. Amen. So no, that's awesome. We really appreciate you being here, being a field expert. And so since we're going to be specifically focusing on NPT tapping today, it's a little different than your standard tapping. Could you tell all of our viewers on the stream, maybe what are some of the key points that make NPT tapping so unique and different from your standard processes?
Yeah, there's actually two specific things that make this unique. Number one, NPT is national pipe thread. So anybody that needs to pipe or thread a product specifically for a water line, a pipe, or anything like that, you would need to use an NPT tap. Second is, versus a standard tap, is that the first couple teeth on a standard tap is what's doing the work. But on a pipe tap, by the time the tap physically stops and reverses, all the teeth are engaged because there's a taper on that tap. So as you screw a pipe in, it gets tighter and it'll eventually stop. Where, if you have a through hole and it's threaded all the way through, you could screw the bolt until it bottoms out on the shoulder.
Very nice. Spoke like a true expert. So awesome. Well, I appreciate that. And so what we're going to do, I know everyone's waiting to see the demo. So what we're going to start off with is we're going to be working with not one, but two of our hydraulic units. We're going to start off on the GH45, and we're going to be doing a 3/4 14 while also featuring our rod style auto depth stop. Nick, you want to talk to us a little bit about what we're doing and what we're looking at here?
Yeah. Oh, yeah. So this is the GH45, and just like Danny was saying, NPT takes, with all those threads engaged, takes a lot of torque. So we're busting out the big guns here. This is the GH45. This guy's going to be putting out close to 400 foot-pounds of torque. So that's what it's capable. So for this one, we're going to be running our 3/4 14 for this guy. And I'm just going to pop it in here, and I'll show you. So the depth stop that Eddie was mentioning, because obviously with the pipe taps, depth's critical. So here we just have a simple depth stop. It's a rod and plunger system. I set it to my desired height, and it's going to maintain that depth every single time just to eliminate any operator error. So I'm going to fire this thing up, and then we'll let this, like I said, this is a 3/4 14. I'm going to fire this up. We are running this one at, I think I'm doing this, let me double check my board. I'll dial an RPM. I'll get it set for 82 RPM. Oh yeah. So I'll just get some lubrication here, and we're gonna line it up over the hole, and we'll just let the arm work and the tap drive on down in there. Tons of torque. It's gonna go until this bottoms out. There we go.
Now, Nick, could you explain to us what happened when it met with that surface?
Yeah, so here, all this is doing is interrupting that forward motion, so then I can just activate reverse. So you can see that it's just a movable plunger here. Now I'm going to clear off these chips and let's check that thread quick and see how it looks.
Very nice. And now we're getting this all set up. Danny, I want to toss it up to you. So I know we talked a little bit previously with a couple of individuals on the high pro pipe taps and then also the A taps. So could you explain to us a little briefly, what are the difference between those two specific type of taps?
Yeah, let me kind of just give you a full analysis. You know, both our Hypro Tap and our A Tap are both HSSE materials. The Hypro Tap specifically is an interrupted thread, so the teeth are staggered. And if you noticed in the last video or demonstration that you shot, that staggered teeth breaks the chips up into small manageable chips. When we talk about the A-Tap, I'm going to go a little bit more into detail, but this product, being an HSSE material, TIC encoded, it only comes in an NPT and an NPTF.
Gotcha.
Okay, so what are some of them? Yeah, you say NPT and NPTF. What does that F stand for? I'm curious.
It stands for fuel.
Fuel. Okay.
And
okay.
The difference between an NPT and an NPTF is the F being for fuel. It needs to dry seal.
Good deal. Good
All right,
deal.
so hey, I want to show why we got the camera on here. You can see I put the my thread checker gauge in here. I've got that flat just underneath there. You can hopefully you can see it with the camera. But so we've got that depth set, and like I said, we were able to achieve that. Obviously, running a nice tap, clearing out those threads, and then using this depth stop to guarantee that we are hitting that depth every single time. Mm-hmm. So that looks beautiful.
Very
I
good.
want to flip flop. We're gonna the next one up. If Tiffany can show this guy on this next unit, obviously takes a little bit more torque. Maybe Danny can talk about that with these big guys. You know, as running this tap as opposed to thread milling, would there be a big time difference in your opinion, or?
Well, with thread milling and having to generate a tool path and everything, you're able to tap at a relatively much faster speed than you would thread milling. Thread milling absolutely has its application, but you know, in the example you have right now, a lot of the older machines, when you get into this big tapping, they don't have the capability to run a simultaneous X, Y, and Z motion. So thread milling may not even be an option. And looking at this application, a lot of the older machines that have a lot of high torque, you're going to be able to tap it at equivalent speed as a
Right on, right on. So Nick, we'll be starting off with the half-inch. And so what we're going to do to let everybody, all the viewers know, we're going to be doing two different sizes of taps on this GH60. Now this is our biggest and baddest tapping arm that does have a tap capacity of up to 2 inches in mild steel. But we're going to start off using the half 14 and then showing a little bit of our auto depth stop. And then we're going to be transitioning over to that 1.5 11.5 while also using the auto depth. So what are we getting ready to do, Nick?
So the first one I have set here, so this unit, unlike the last one, just to control that depth we were talking about, I'm going to use our digital depth control. So I've programmed in the pitch for the tap, which is 14, and I've set the depth for 0.85. So I'll pop this thing in. I'm in gear 2. This unit, because this is a smaller tap, I don't need to run it in my high torque gear. So I'm gear 2. I've set the pump here. We're going to run this at 132 RPM. I'll set it on auto, and we're ready to go, guys. I'm gonna get some lube on there, bring it over and let it eat. That one's pulling the chips right up nicely. Automatically hits the depth, and now it's coming back out, and just gorgeous threads. I'm gonna clear this off here, and let's get our, we'll double check the depth, see if we need to adjust it at all.
Now that looks good. So Danny, can you tell us a little bit about this half-inch 14 tap we're using today? Oh, actually, hold on, we got a question here. Okay, go ahead, you use first, Danny, go ahead.
No, it was okay. You know, we're very excited about this last product that you showed. This is OSG's new A brand lineup of taps. Under the A brand, we've spent a lot of R&D redeveloping geometries, cutting conditions, And this product right here, being a pipe tap, it still has a variable geometry helix on the flute, which allows it to create a really nice chip and start getting it to curl, and then that variable slows down, and you could see when you were tapping, it curled the chip up and allowed the chip to evacuate very effectively. When chips are the biggest contributing factor to tap failure and galling of the threads, you know, it's really important that you maintain good chip control. And with this Abram product, like I said, we're very, very excited about it. The Hypro tap that you showed and even the standard tap that you're getting ready to show, most of them only come as a standard length NPT or NPTF. Under this flagship product, we now are offering a complete product lineup for these types of threads because we now offer it in a standard length, a 4-inch length, and also a 6-inch length. And we also offer this in a BSBP, which is a British standard, pipe tap. So this particular product, by that variable geometry, we're really able to do some outstanding things that we were not able to do previously in our product lineup.
Yeah. Very informative, very informative. And I saw, Isaac, we had a question that you had pulled up. You want to pop that back up, please? Just to make sure we can get those answered. So my man, Logan Skelly, thanks for commenting in, man. What tolerance can the depth stop hold?
Yeah, so that's a good question. So obviously when I'm dialing in that rod or adjusting that here, I mean, we're usually on the depth, within a couple thousandths. So it's trial and error to get it set, but then once I have that set, it's going to consistently run to that depth every single time. So it's a good question. But and if you can,
well, Brian Marsh, let's see. Can you talk a little more about how the digital depth works? Nick, can you dive into that a little bit?
Yeah, I wish I could show you guys a screen. We're not really set up for the camera to come back here, but it's really simple. So I'm just going to take the pitch off of whatever tap I'm doing. So like in this case, 14. So there's an auto selector here. I'll hit 14. And then right after that, I'm just going to set the depth that I want to go initially. So, and then I'll trial and error. So if you can look here, bring the camera down a little bit, you can see, I set this, in this case, the first round we did 0.85, and that put me right at my nominal, this checker has 3 different flats. So on the back side here, I'm right where I need to be. So I'm happy with that. Maybe I'd adjust it down 50 thou more or something like that. But no, so I set the pitch for my tap, and then I set the depth. And then it's as simple as on the controller here, you'll see me. On this next one, I'll show you guys a little bit better. I'm going to hit start, and then I'll let go. It's going to automatically run itself down and then automatically reverse. And all that's happening is it's counting the revolutions. So you can actually see the little encoder back here, and that's what's behind the scenes in the program. We're just counting the revolutions in that gearbox to drive it to the same depth every single time.
No, that was a great question. Great question. So Nick, you want to transition over to that half 11.5 or inch and a half?
No, pretty happy with this. This turned out well.
Right on. And while we're doing that, so Danny, as we switch over and we go to this inch and a half 11.5, I know you're excited to talk about it. It's the big one. So tell us a little bit about it, man.
Yeah, this is a product that's been around with OSG for a very long time. We have absolutely phenomenal results with this product. Like I was sharing earlier, this particular lineup allows us to go over 1 inch all the way. We have product lines that obviously start from 1/8 of an inch MPT all the way to 2-inch MPT. Because this is a product that's been around for a long time, we're able to cover a broad range of materials. It's specifically designed to be able to tap, especially with the TIC encoding, from aluminum all the way up to medium and non-heat treated tool steels.
Okay, and as Nick gets this all set up and finalized, I'm curious, so what other type of materials would you see these 2 taps being used for, or used with, essentially?
Well, with the exception of everything that I've already mentioned, with the 8 tap, and the TIC encoding, we're able to get more into the pre-hard materials, the stainless steels, a much broader range. So about anything that you see in a job shop, we're able to do. We do well in aerospace materials, but you start getting into extremely hard over 42 Rockwell, we need to start looking at a different option.
Okay. No, solid insight. Thanks for that, Danny. So, Nick, are we ready to rock and roll on this 1.5 inch?
I think so.
There we go.
You guys saw me down there. I got the depth set here to 1.25. This is 11.5 on my pitch, so I've selected that. And then RPM, now we're in low gear because this guy's going to take some torque. And I've got that set at 33 RPM for this tap. So I'm just going to, like I said, I'm going to bring it over, line up over the hole, and we hit start. So we're going to let it do its thing down there. Tons of torque.
So, Danny, while this is running, can you tell us a little bit about what's going on with the chips here, man? What are we seeing?
Yeah, because this is a straight fluted tap, there really is, by design, no chip control. So our goal at OSG on this tap was to be able to try to break them chips in as small as possible, as opposed to the other 2 taps that you saw. With the spiral flute, we're specifically trying to get that chip out of the hole as quickly as possible.
So you can come on down there and take a look.
Good deal. Let's check out the threading that we have here. Good deal. Looks very nice, very nice. Now, Nick, do you want to explain a little bit kind of what happened with that digital depth control there when we saw that? Yeah.
So you guys saw the hands-free part of that. I mean, as soon as we kick that on, I mean, I'm just letting the arm work. So it's going to automatically go down to that depth and reverse. The arm just takes all the torque. It's effortless. So makes it super easy. And just for fun here, I say we run one more.
There we go. Let's do it.
Making beautiful threads. I wish I had a go, no-go for this size, but I do not. But I mean, we're taking it 3/4 of the way down. Just torque's obviously not an issue. Hey, Danny, quick question on the length for these NPT taps. I noticed that 1/2 inch is very long, and then a couple of our other taps here seem to be shorter. How does that vary? When I order, do I have to request, hey, I want a longer, like, pulley style tap, or?
Yeah. Each individual one has its own unique EDP number. So if a customer calls in and asks for and specifically says, hey, all the taps that you're seeing in the shorter length is what's called or known as an ANSI standard. It has a specific length that it needs to be manufactured to. If a customer needs something that's longer, they just need to request and let us know what length they need. And then and like I was sharing earlier, they just, we have up to 6-inch overall length taps.
Gotcha.
Well, right on. Well, Nick, is there anything else we want to go over when it comes to demonstration-wise with the 60 or anything along?
No, other than that, I think I do know here in a couple weeks, Danny, I think we're going to try to put together something using the dies. We're going to do some external threading just to show what that looks like using your guys' dies. So that's something to look forward to.
Awesome.
Other than that, this was fun. I mean, the awesome taps, tons of torque here today, and hopefully we were able to educate some folks on NPT tapping, what it takes, and a little bit of the ins and outs. So.
Yeah. And then now, with it being kind of my favorite part of it, we've gone through the demonstration. Isaac, if we have any general questions, I'd love to pull those up. If not, Danny, I know I did some homework, and I'd like to ask some personal questions as well. So let's start off with is it truly necessary for someone to pre-ream the taper inside of a hole?
Well, obviously, with all the teeth being engaged at one time, if a customer chooses to pre-ream that hole or pre-put that taper in it, you're you're obviously taking a lot of stress off the tap. It is not necessary to pre-ream the hole, but if a customer is really looking to control, you know, the tool life, then reaming obviously would be a better choice. But it is not necessary. With OSG taps, we can go ahead and tap that hole without reaming the part.
Now, what if the thread is dry seal?
There's really no difference between the tap itself other than the geometry that's built into the tooth. So whether, you know, speeds and feeds, reaming it doesn't matter. It's still, even the drill size, the pre-drilled hole size is exactly the same. The biggest difference is when we talk about the dry seal, is not so much, you know, it's when it's assembled. So every one of us has used Teflon tape on a piece of pipe and screwed the pipe into a thread. With the dry seal, they're physically mating the two parts, and because of the geometry in the tooth, it creates a seal, and so there's no type of sealer that needs to be used.
Okay, well, right on. Hey, so Isaac, do we have any general questions in the comment section you want to pull up? Michaela Saunders. Hi, Daddy. Oh, for those who don't know, that's my daughter. Oh my gosh. I love you. I love you so much, sweetheart. You absolutely just made my day. Isaac, oh man. That was unexpected. Okay.
Yeah, I wasn't
I'm supposed to focus
expecting
on NPT taps when you got cute stuff like that happening. So little surprises. Well, with that, thank you, Danny, so much. And lastly, for anyone who wants to learn a little bit more about OSG or NPT tapping, where do they look? Where do they go? How can they find you?
Absolutely. You know, one of the things I'd like to say, Eddie, is I shared at the beginning about our sales staff. We have over 55 district managers in the United States that we could go and support our customers. So if the customers, you know, have a specific need or a specific question about our product, it's easy. Just call 1-800-837-2223 or go to our excellent webpage, which is www.osgtool.com.
Not just a web page, an excellent web page. And speaking of excellent, Danny, it's been excellent to have you here with us to bring your expertise into it. Thank you, Nick, for the help. And before we head off to it, just get you some good view here so we see what's going on. What's a good angle? There we go.
Right there. Oh yeah. Let her focus. Those pretty threads.
Look at that. That's what happens when you team up OSG with FlexArm. Good things, man. Right on. I dig it. I dig it.
Absolutely.
Well, Danny, again, thank you on behalf of FlexArm and OSG. Anyone who's viewing, we appreciate you. Please do not forget to subscribe, hit the notifications so we can keep you in the loop, and give us what my lovely daughters would say, a huge thumbs up. Also, make sure to check us out. We just revamped our website. See us on all the social media channels. We'll make sure to keep you in the loop. But above all things, stay awesome, stay flexing, and catch us on our next episode. We're going to be doing some plasma laser cutting. See everybody later.